This is Nicomp training on how to measure a size standard using the ZPW software platform.
First, we'll prepare a 10 millimolar sodium chloride or potassium chloride solution. We'll filter this to remove any particles. We'll then take 30 microliters of the standard and dilute that into 5 ml of the filtered salt solution. Take measurements that are 5 or 10 minutes long and check the result to the standard. The graph you see here shows the difference between measuring this sample in DI water as opposed to a salt solution, and you'll see sometimes you can get away with it. More often you're better off doing it in the salt solution. This graph is part of a larger technical note, which you see here, which will explain all the details of how to take these measurements using the size standard.
Here I'm going to use the round glass cells in the black cell holder. I place the tube into the black cell holder. I'm going to pipette the standard into the cell so that it is above that cutout where the measurement is made. Then I can take this cell and load it into the instrument for measurement.
The orientation of the cell as we place it in the instrument for measurement is important. As we face the front of the instrument, we want the solid metallic side to the left and this cutaway where the measurement is made facing to the right as we place it into the cell holder.
Load the cell oriented as just described. There's a black plate in here you move over to the left and make sure that this is in the position for size, not zeta, if it's a zeta system, and then close the door. Here we see the software settings for making the size measurement. In the upper right, under the control menu, you see we set the viscosity to 0.933. In the other settings you see fixed here. In general, we leave everything on automatic until you become more adept at using the system. Here we're looking at the Auto Print Save menu where we enter the printout ID, and we've decided to make 2 measurements of 10 minutes each. And then we're going to save each measurement as a file name. If we click on Browse here in the lower right, we're going to choose the file location and then a name for this measurement file. A funny thing about this software is that file name must end with a name, period, and a number, such as you see here, video 1.1 or PSL 2.2. Click Save, and then we are ready to make a measurement, as we will see in the next screen. In the software, we're going to click on Particle Sizing and initialize ND, or Neutral Density Filter. Now an optical filter is rotating to optimize the particle count rate, typically near 300 kilohertz. So we'll wait until it completes this initialization. When it's completed, we click OK, and then we have 2 screens to set up. Particle Size Control Menu. Here we make the settings as described in the slide. This all looks like it's fine. We'll click OK. And then under Particle Sizing, the second menu down, Auto Print Save menu. This is where we enter the printout ID, how long we're going to take the measurement, how many measurements. Next we click on Browse, and this is where we enter the file name, which remember must end with a period and then a number. If we click Save and then OK, we now have set up to make this measurement, and we click G to begin the measurement. After a few minutes, the size will start appearing on the screen, see 93 nanometers. We can click on Display and come down to Time History. And here we could focus on this red value, the intensity weighted mean, and we want to make sure we measure for long enough for that value to have stabilized.
While we're taking the measurement, there are some other views we can look at. We can go to Display Correlation function. This is the raw data. We want to see under decays around 2.5. We can come and look at the correlation data. Not much we can do with it. We can look at the channel error where we want a random distribution of noise. We can look at the time history again. We see the red intensity mean hasn't stabilized yet. We need to keep measuring. Go to Show Distribution to come back to looking at the particle size distribution. Click on this G and N button to switch between the Gaussian and the Nicomp distribution. Weighting allows us to look at the intensity, volume, or number distribution. Here we can look at both the intensity and the volume distribution, or come back up and we'll come back to our usual look, intensity distribution.
And if we come back to display and look at time history again, we see that the red intensity weighted mean is now stabilizing. So you can see with this sample, after about 3 minutes, we have measured long enough to get this nice stable result. Here is the result of the measurement we just made of the 92 nanometer polystyrene latex standard. The number we focus on is here, the intensity mean diameter. The certificate of analysis for this standard is 92 plus or minus 3 nanometers. We see we got a perfect result there. If we're doing the IQOQ procedure in the pharmaceutical industry, actually the range we're allowed here is plus or minus 15%, so we actually really nailed this result. The number you see here, the variance or PI, which stands for polydispersity index, that number should be very low like we see here. Now, if you didn't achieve a good result, usually this would mean that it's too large. That means it's usually something associated with the standard. Either it has aggregated or we need to work on the sample preparation. And the place to first focus your attention is how clean is the diluent, the salt solution or the DI water you used to dilute the sample, or maybe the beaker used to prepare the sample.